So yesterday, 7th graders, we talked about multiplying powers. When you multiply powers, you add the exponents. And if you're dividing powers, you subtract them. Because multiplying and dividing are opposites. So the opposite of addition is subtraction. Okay? That's basically what we're talking about. If you have the power written as a fraction, then a to the fourth minus 6 gives you the answer. Okay? Now there's a couple of concepts though that we have to talk about. One of them is that, first of all, any number to the 0 power is 1. Is just the answer 1. Any number to the 0 power is 1. So look at this example right here. A to the third over a to the third. Okay?
So basically they're the same.
A to the third over a to the third. Now, since we're dividing these, we have a to the third power on the top line over a to the third on the bottom line. Remember when you have the same number over itself? A over a is 1. B over b is 1. So what if you have a times a over a times a times a? That's 1. Or they're all canceled out. So the answer is 1. That makes sense, doesn't it? A divided by a is 1. What's a divided by a, Max?
A divided by a would be 1.
1. What's another a divided by another a?
It
would be what?
It
It'd be 1 times 1 times
Never
1
mind, don't listen to
over 1 times 1 times 1, which is 1. Or, let's apply what we're talking about today, where you're subtracting the exponents when dividing. If you have 3 minus 3, you have a to the 0 power, which is 1. Okay? What if you have a negative exponent? What does that mean? Let me show you. Look at this example. A to the fourth over a to the sixth. If we wrote this out in expanded form, it would be a times a times a times a over a times a times a times a times a times a. So 4 a's on the top line, 6 a's on the bottom line. When you cancel them out, all you have is 1's on the top. So that's simplified to just 1. And you have 2 a's left over on the bottom. So it's a squared on the bottom. Right? So 1 over a squared is the answer, isn't it? 1 over a squared. Now, what if we subtracted? What if we used subtraction to simplify? Look at this. A to the fourth minus 6. What's 4 minus 6? Negative 2. So isn't a to the negative 2 the same as 1 over a to the 2? Isn't that the same then? It is. Yep. Logically, it has to be the same. If this is the answer for the subtraction, and this is the answer when you write it out in expanded form, then these are the same answer. Right? So then what does the negative exponent mean? Instead of a to the negative 2, it is 1 over a to the positive 2. What does the negative exponent mean? What does the negative exponent mean? Look at this. Here's the example. Oh, Garrett, go ahead. You got it?
Well, I was thinking it would equal the 1 because the 1 isn't in the other one.
The 1 isn't in the other one. Where did the A go? Instead of being on the top,
To the bottom.
it went below the line. It went to the denominator, didn't it? Look at this concept. N to the negative 3 is the same as 1 over n to the 3. In other words, if you move a power from the numerator to the denominator, it becomes its opposite. You're moving it to the opposite side of the division bar, or the fraction bar. If you're moving it to the opposite side of the fraction bar, then it is the opposite. It becomes either from negative 3 to positive 3, or positive 3 to negative 3. Okay? So let's practice this. I think you can get all these positive ones. That's really simple. But the negative exponent is something pretty new. So let's do some practice from your sheet. Okay? You don't have to copy all of these examples. Just copy this circled one. Copy this circled one. Make sure you have this circled one copied. Okay? A to the third over a to the third equals a to the 3 minus 3, which equals a to the 0,
Wait, what does that mean?
which equals 1. Sam,
Wouldn't that mean it's times 0? Or there's no exponent?
there's no exponent.
So it's basically just the same.
It's just 1.
Yeah.
Just the answer 1.
Wow!
Okay? Just 1. Just 1. No A. Because all the A's are canceled out. They're all divided by each other. Okay? So let's look at some together. Number 1. 7 to the 8th over 7 to the 2nd. On the line, write 7 to the 8 minus 2. And then write 7 to the 6th. Number 2. X to the 5 over x. If it's just an x, what is the power of that one?
1.
Not 0, because that would just be 1. So this is x to the first power, isn't it?
Oh, right. Yep.
Right? Think of it this way.
Because there's only one x.
Think of it this way. This is x times x over 1x. Right?
Yeah.
That's what x to the 5th over x looks like in expanded form. So, when you cancel each one, x divided by x is 1. And what are you left with?
4.
X to the 4.
I did it.
Or x to the 5 minus 1 is x to the 4th power.
What about 5 to the 0th power?
That's 1, isn't it? Any number to the 0 power is 1. Any number to the 0 power is 1. So 5 to the 0 power
What about a negative?
is 1. Okay? This one, n to the negative 3. That's number 4. This one's in your notes, isn't it? What does n to the negative 3 mean? Adam?
Means there's like negative 3
No.
It's all negative.
We move it to the, right, n to the 3rd power. It means 1 over n to the 3rd power. Okay? That means 1 over n to the third power. Remember, when you move this from the top down below the fraction bar, it becomes positive.
Why do you have to do that?
You have to, just so you understand the concept. So you know, sometimes you will have to do that. Okay? Number 5. X to the negative 2 times y to the 4. We have to move this one. That's all we can do on that to simplify it. Where would we move it to?
The bottom. The top. The bottom.
Move this one below the line. X squared.
Oh, right.
Instead of x to the negative 2, we move it into the denominator and make it x to the positive 2. And leave this one on the top. Y to the 4. Next, are you copying these? We're on number 5 already. On your sheet. On your homework. Sam,
Wait, why would X go to positive?
why wouldn't x go to positive? What do you mean?
Why would the negative go to the positive?
Why would the negative go to the positive? Because it's like this. How could we get a negative 2x? By subtracting like x 4 minus 6, right? So what that means is, if we had x, let me make a 4 on the top and 6 down below. And when you cancel them out, how many are left? 2 down below, right?
Oh, so then it would.
So then by moving it down here,
And it's on the bottom.
it makes it positive.
And it's on the bottom.
Y goes to the top because it will be that times the 1, right?
Y is already on the top. Yep. Whenever you have something written as a whole number, it's automatically over 1. It's automatically on the top. It's only when it's written below the denominator that it's on the bottom line. Okay? Number 6. 6a to the negative 3. What's the base of this exponent? Does the negative 3 go at the 6?
No.
No, it's not in parentheses, is it? So remember that concept from a few days ago when we were talking about parentheses? It only goes with the a. So we have to move this to the bottom. And leave the 6 on the top line. Right?
Yep.
That's a whole number 6. 6 over 1. So this is 6 over a to the third power. Yep. All right, keep up with us. What's negative 4 to the 0 power?
1.
Good.
1.
What's b to the third over b to the 8th? Oh, that's 8, sorry.
That's fine. No, it's just 1, yeah.
What's b to the third over b to the 8th?
B negative 5.
1 over b to the 5th,
The first.
or
B to 3 minus 8.
which is
B to the negative 6.
good. It's either b to the negative 5th, or it's b to the 1 over b to the 5th.
Does that mean
Okay? So there's a bunch of examples for you. Alright? You have to think through these, but this is, it's kind of fun. It's a puzzle.
Can you show us 10
All right, number 10?
Yeah.
Yeah, there's like
Oh,
a
10.
variable.
Okay,
or like
all
a
right,
number
one
that
more
variable
example.
then-
It's impossible.
One more example. Number 10. 7s to the negative 5th. T to the negative 3rd. Where do these need to go?
At the bottom.
These go down.
Oh.
This stays on the top line, doesn't it?
Oh.
S still makes sense.
Yeah.
You make a fraction bar. Make a fraction bar. S to the 5th. T to the 3rd. And 7. Okay? So you can copy that one as well. Look for the patterns. And do the evens on the other side. Again, evens on the other side.